Have you ever wanted to turn back time in your coding project? Or maybe switch between different versions of your work effortlessly? What if you could try out new ideas without worrying about messing up your main project? Today, we are going to unlock one of the Git's most powerful command, Git checkout. By the end of this video, you will understand what Git checkout is, why it's important, and how you can use it to manage your project like a pro. Over time, we have saved different versions of our project using commits. Now let's say we need to go back to an earlier version or switch to a different branch. Going back to a specific commit or switching branches is easy with Git checkout. It allows you to switch between different commits or branches in your project history. Here is the list of commits we have done so far. I am viewing the commit log in one line. If you want to know how to check the list of commits in your Git repository, you can watch my previous video. You can get the link in the description. Now, this is our latest commit at the top. Here, head is pointing to the master branch. Now, let's say we want to go back to this earlier version. To go back to this commit, we need to use git checkout command. First, we need to copy the commit hash. For example, here is the git hash for this commit. Now, we type git checkout, then provide the commit hash. Executing the command. When executing this command, you will see a message. You are in detached head state. Many developers becomes confused by this message when using Git. Let me explain it in a simple terms in my own words. Suppose this is our initial commit. We have just set up our project, initialized a Git repository and committed the changes for the first time. After that, we made some changes to our code and made another commit. Each time we make a new commit, Git stores a complete snapshot of the project at that moment and also keeps a pointer to the previous commit. For every commit, Git forms a chain of commits. This chain makes up history of your project. Git keeps track of these commits by pointing each new commit to the one before it. Now, while working, you or your team member might decide to experiment with the project but are not sure if it will work with the main code. So, you can create a branch from any of these commits and continue working on that. Each branch has its own commits, allowing different developments to happen at the same time. This makes it easy to make multiple features or versions of your project. We'll talk more about branches in another video. Now, your Git repository can have multiple branches. But how does Git keep track of each branch? Well, Git uses a pointer to do this. Let's start from the beginning again. This is our first commit. When we make the first commit, Git considers this commit to be under the default branch. The name of the default branch is usually master. So, Git has a pointer named master to identify the commits that belong to the master branch. Every time you make a commit, the master branch pointer moves forward automatically. Now, let's say at this point, we create another branch called testing. Here, Git creates another pointer for the testing branch. So, whenever you make commits in master or testing, Git keeps track by moving the pointer forward along with the branch. But how does Git know which branch or commit are you currently on? For that, Git uses another pointer called head. The head pointer tells us which branch or commit we are currently on. Normally, head points to the latest commit in a branch. In our project, our head is pointing to the master branch. However, when we check out a specific commit, Git moves its head to point directly to that commit. If we checked out commit that is not the tip of a branch, head points directly to the commit. This is what known as detached head state. That's why Git is showing you this detached head message. Now, when in a detached head state, you should not make any commits. You can look at or experiment with the code, but do not make any commit. If you need to make changes and commit them, then create a new branch from that commit. Creating a branch is easy. You can do this by typing git checkout, then -b for branch, followed by a space and provide the branch name. This creates a new branch and switches you to it. When you are satisfied with your changes, you can then merge that branch with your main branch. If you don't do that and you make a commit in the detached head state, then what will happen? Because the commit you make is detached head state is not attached to any branch. It might get lost if you switch branches. Git does not have a branch pointer to remember it and might eventually remove during the cleanup. So it's important you must not make any commits while in detached head mode unless you have created a new branch. Now if we check the git log again, let's view this in one line. You can see only the list of commits that were made before the commit that we have checked out. If you want to see all the commits, you can type git log, then I want to see this in one line, and we need to provide additional option --all. This all tells Git to show all the commits. This shows the commits from all branches. In my case, I am on the master branch. Here you can see this is our latest commit at the top and our head is pointing to this commit. After you have finished exploring, you can check out back to the latest commit on your main branch. Simply type the command git checkout, then the branch name master. Now our head points to the latest commit of our master branch. Let's check it by typing git log --one line. Here our head is pointing to the master. Git checkout is a powerful tool that lets you move around in your project history and work on different branches. Remember, if you need to make changes when you are on an old commit, always create a new branch first. This way, you keep your work safe and organized. Now consider this situation. You have removed a file in a previous version of the project, but now you realize that you need that file for the smooth operation of your project. So, how can you get it back? Do you need to check out the earlier version where the file existed, commit the file, and then check out the latest version and pasting it into the working directory to use it? Or is there a more convenient way to restore the deleted file? Well, we'll cover that in the next video. Just click on the video that appears on the right side of the screen to go to the next video. Thank you for watching. If you found this video helpful, please like and subscribe for more tutorials. And don't forget to check out the next video to learn how to restore deleted files in Git. Happy coding!